Hello, let's get started. This is Computer Science 1410. My name is Joe Zachary. And first thing you need to learn is how to ride a bicycle. First lesson is always wear a helmet. It doesn't matter how fast you're going, it's how far you fall. So if you fall off the bike going slowly in front of this room and hit the wrong thing, you can get hurt. I can't figure out how to put it. Okay. Who knows how to balance on a bicycle? How do you do it? Yeah.
You keep your center of mass over the support of the bicycle, right?
You keep your center of mass over the... something, you said?
Bicycle frame.
Is that how we all do it? Just do it? Yeah? Yeah. Training wheels? Well, I don't have any available. And actually, I debate that. I know from teaching my kids that training wheels were different. Didn't really help, I don't think. Except maybe a little confidence. Yeah? It helps to be moving, that's clear. It's a lot harder to do a track stand. You see people trying to do it at stoplights. Some people are good at it. Most people can't balance very well when they're not moving. So there's something about moving. Okay? What is it about moving? Yeah? Say louder. All right, I can only guess what you said, but I'll try another one. Yeah. That doesn't work either. You have to talk really loud if you want to answer a question. Move the bike forward, you what? Okay. So, yeah.
If you're falling left, go left a little bit so you can go forward.
Right. So when we're riding forward, you know, we can basically shift our weight by turning the steering wheel with the handlebars. And then you balance. So as you ride along, you're just making minute corrections. Now, this is sort of advanced bike riding. So most of us don't think about it very much when we're riding a bike. But it's actually, it just becomes second nature. It doesn't take kids that long to learn it. And the faster you go, the better you balance. Why is it that going faster makes it easier to balance? Why can those Tour de France riders lean into these curves and they're coming down the mountain? Yeah? Go ahead. Say again. I can hear you. You've got to use your outside voice in here.
Rotational inertia.
Rotational inertia, right. So there's inertia in the wheel. So it's really easy to do this, but if you get the wheel moving at all fast, it resists. You can feel it. It resists turning. So if it's going like this, it doesn't want to change. So the faster you get these things moving, the easier it is to balance. Okay, so you must be wondering why I spent the first 5 minutes of class talking about riding a bike. It's because I want a teaching evaluation. I want to know what you thought of my method of teaching how to ride a bike. Did I give a good lecture on riding a bike? A bad lecture? What do you think? You're never too old to learn.
I think you have more experience on lectures than I do, so I trust your opinion more than mine.
Okay, he said, I have more experience than he does, and so he trusts my opinion. But I want your opinion. Yeah?
I think all of us, well, if supposing that you were talking to someone who's completely clueless on riding a bike, I think everything you said was correct, but you didn't give them some vital information on, like, where to start.
Okay. So she said someone didn't know anything about riding a bike. I gave them some crucial information. But I didn't really tell them where to start. What's the fundamental problem? Way in the back, outside voice.
You have to do it yourself to learn.
Exactly. None of you learned to ride a bike by having your mom or dad give you a lecture and a demonstration. You got on the bike, your mom or dad pushed you, and you either fell over or you didn't. And then you got back up and did it again, and did it again, and did it again. Okay? So, I make a big deal about this because during lecture, when I'm up here talking, I'm the one practicing programming. I'm the one learning to program better. I learn a lot by teaching. If all you think this class involves is showing up and listen to me yak for 80 minutes and then you go home, you're not going to do very well. You're not going to learn to program by listening to me. I can point you in the right direction. I can give you encouragement. I can choose the order in which we do topics. And I do all that. But you are going to have to learn how to program by doing it yourself. So keep that bicycle analogy in mind as we go forward. Okay, now we're going to turn to computer science. And there are a couple things you traditionally do in the first lecture of the semester. One of them is go over the syllabus, and I'm going to do that. But first I want to give you a view from 60,000 feet of what it is we're going to be learning about. And right now I'm not even connected to the internet, so bear with me for a second. Okay, so here we are. This is my. I don't like this either. Oh well, live with that. CS 1410. There are actually two sections. There's section 1 and there's section 50. Are any of you in section 50? Okay, one person. Okay, section 50. Section 1 is the regular section, and that's what most of you are in. Section 50 is called the hybrid section, and it's exactly the same as section 1, except it says online that you don't come to lecture, that you watch the lectures on YouTube. However, the combined population of two classes is only slightly bigger than this room. So people from section 50 should be able to come, especially after the first week, without causing any trouble. Similarly, you guys, if you miss a class for some reason, you can watch it on YouTube. Assuming we can get it up there, that's what we're struggling with up here in the front, the new classroom. So our goal is to live stream the lectures to YouTube. Today it looks like it's going to be uploaded after the fact. But that's how it goes. This is my contact information. It's, you can find it lots of other places. But I want to emphasize one thing. I have office hours on Tuesdays and Thursdays from 1 to 4. That's when I promise to be in my office to answer questions. However, I have an open door policy, so I'm in my office a lot more than from 1 to 4. Sometimes if I'm really busy, I'll close the door. But if I'm in the room with my door open, you're welcome to come in and ask a question. Okay? So the only difference between every other time and office hours is I promise to be there during office hours. Other times, it's sort of a crapshoot. Now what this class is an introduction to three things. To computer science as a field, to object-oriented programming as a way of programming, and to Java as an object-oriented programming language. So we're sort of doing all three at the same time. There are four key concepts that sort of govern everything we do. Number one is decomposition. Right? What does decomposition mean? It doesn't sound very pleasant, but it turns out to be very crucial. Yes?
Breaking down a problem into smaller pieces.
Okay, he said breaking down a problem into smaller pieces. Okay, let's see what I said. Okay, I said it in a lot more words. Dividing a problem into simpler problems that you can solve, and then combine those solutions to solve the original problem. So that's something computer scientists do all the time. Break things up into small pieces, solve those, recombine. Decomposition. Algorithm, another key concept. What is an algorithm? Yeah.
It's a series of steps to solve a problem.
Okay. Series of steps to solve a problem. A step-by-step description of how to carry out a task. Okay. That's algorithm. Representation. What is a representation? What does that mean in the context of computer science? Well, yeah.
Using variables?
No, it's not using variables, yeah.
Something that stands
something that stands for something else, getting closer. It's a plan for building something from simpler pieces. Okay? Basically a plan for building something. Usually a theme. And finally, there's abstraction. What is abstraction? Yeah? A simplification of a complex thing? Yeah. A lot of us, when we hear the word abstraction or abstract, you think about abstract art or something like that, and it seems kind of like a fuzzy concept. But by abstraction, we mean taking a simpler view of something by selectively ignoring details. Okay? And that's a crucial skill in computer science, being able to take something complicated and make it and think about it in simple terms. After all, when you use a computer, it's hideously complicated. If you had to understand every detail at every level of how a computer works, you'd never do it. No one can. But they're easy enough to use. You're abstracting a lot of the irrelevant details away. So let's just let me illustrate these concepts, because they're gonna come up again and again throughout the semester. We'll start with decomposition. So here's a bicycle. Suppose you'd like to describe how to build a bicycle. What are the pieces into which a bicycle decomposes? Yeah.
Wheels.
Wheels. What else? Yeah. Frame. Yeah. Pedals. Yeah. Seat. Okay, you got the idea. Here's some of my stuff, but frame, fork, wheels, drive system, gear system, braking system, seat system, steering system. So that's one way you might decompose a bicycle. Here's another way you might decompose a bicycle. And I call that a bad decomposition. What's bad about it?
No abstraction.
No abstraction, yeah.
It's taking every last thing apart.
Yeah, it's a good decomposition. You don't say a bicycle's made up of ball bearings and screws and some alloy of steel. Or, yeah.
I think
Good.
maybe one thing that would make it a good decomposition is if you can see, you can have an idea by looking at the decomposition of what the whole is supposed to be.
Yeah, it should be easy to, given a good decomposition, this is what she was saying, it should be easy to see how you turn that into a bicycle. So that's a bad decomposition. Here maybe is a better one.
Whereas in that last picture I thought, is there a pig somehow involved?
Yeah, that's the chain. Is that pig at the bottom is a chain. But they're like individual washers and screws here. That's just too much detail. So that's sort of a better decomposition. It's talking about the kinds of things we talked about. Brakes and forks and skewer is kind of a low level detail. I would say wheel instead of talking about the individual pieces, because once you have a wheel, you can talk about decomposing it. So anyway, that's decomposition. Here's an example of an algorithm. So suppose you have a string of digits, base 10, positive number, and you want to know if it's divisible by 3. Okay? So, is triple of 9? We ask if 9 is divisible by 3, we say yes. What about for 10? No. If you say 2301? True. 2302? False. Okay? So here's an algorithm for it. I just want to have an example of a simple algorithm. And we just repeat these steps until an answer is reported. You add up all the digits in the number and call that n. If what you've got left is a single digit, if it's 3, 6, or 9, the answer is true. If it's not, the answer is false. And if it's not a single digit, you just keep repeating the steps. So that's a way to tell if a number is divisible by 3 without doing a division, for example. And I'm sure a lot of you are familiar with it. So just see how it works. So is triple, we try to find out if that number is a triple. So n is that. What's the next step? What do you do with n? Right, add the individual digits, you get 27. Add those digits, you get 9. And it's a single digit now, and that's 9. So the answer is true. Okay? What about that one? Add them all up. Well, that's the number we're starting with. You add them all up, you get 26. Add all those up, you get 8, and that's not 3, 6, or 9, so we're false. So, simple algorithm. We'll be doing lots with algorithms. Okay? Now we're going to talk about abstraction in terms of both algorithms and representations. So, This is how we use an algorithm. Let's suppose you have, in some programming language, created a piece of code that if you give it a number, it'll tell you it's divisible by 3. To use that piece of code, you don't have to worry how it works. You just have to know what it's supposed to do. Someone says, here's a correct piece of code that'll tell you the number is divisible by 3. We say, got it, and we just use it. We don't worry about what's happening inside. That's abstraction. It's taking an abstract view of an algorithm. We're paying attention to what matters, which is what do you get in when you put something out? What do you get out when you put something in? And we don't worry about the irrelevant details, like how does it work? We don't care at that point. So that's an example of abstraction. Selectively ignoring details so you take a simpler view of something. Okay? Now let's talk about abstracting a representation. How are numbers represented on computers? Say integers.
String of 8 zeros and 1s.
Okay, string of bits. Sequence of bits. So there's an example. So that's sort of a low-level thing. What does that stand for? Turns out it stands for 52. So when you're writing a program and you want to know how many weeks are in a year, and you write 52 into your program, do you think you stop and worry before you go forward? You have to wonder, okay, 52, I wonder what the bits are in 52. Does that matter to a program? No, you abstract away from that. 52, you don't deal with the bits, you deal with 52. That's abstraction in action. How is an image represented on the computer? Well, pixels, what about the file? What's in the file, yeah?
Just a large sequence of bits.
Sequence of bits, sequence of numbers, bunch of numbers. Okay? There are different kinds of numbers, it depends on what kind of image you're talking about. So there's a sequence of numbers. What image does that stand for? What image does that represent? Come on, you all use computers, you look at images. Tell me, what image is that? Right? You're very, it's a silly question. You're so used to that form of abstraction. You're perfectly fine using images on a computer without knowing how JPEG works. In fact, that stands for that image right there. Little eraser stuff, pencil stuff. Okay? So that is abstraction in action. It's a lot easier to think about the icon than it is to think about the numbers that go into representing it. Actually, that's a lot of numbers for an icon. That's a lot bigger than an icon. Okay? So abstraction's our friend. So this just summarizes what we talked about. It lets us ignore representation details. It lets us ignore algorithm details. It lets us create building blocks, and then we just use the blocks. We don't worry about what went into the blocks. You've got to master this. Do you think when someone, working at Apple or Google and is working on a million-line program, do you think that person understands in detail how every line of the program works? No. Nobody can do that. They understand how pieces of it work in detail, and they understand in general terms how the whole system is put together. That's abstraction in action. So computer programs, one way to look at them is they're a bunch of ones and zeros. At a higher level of abstraction, you can think of them as a sequence of letters and symbols. At a higher level than that, you can think of them as large collections of simple objects and operations. But you won't be able to make any progress unless you can think of programs as small collections of powerful objects and operations. It's abstraction. Either you get good at it or you don't learn to program, beyond a rudimentary level. And here's something I want you to remember if you don't remember anything else. One thing about computer programming is, if you ask most people what's a computer program, they'll say something like, it's a set of instructions to tell a computer what to do. But actually, when you write a program, yes, it's important to tell a computer what to do. But it is, in many ways, more important that another person be able to read it and understand what it is saying as well. So you're not just describing a computation to a computer. You're describing a computation to people. And that's why you'll see that we harp a lot on style. The computer doesn't care about the style of the program, but we do. People that are reading your programs do. And that's a very important skill. Okay, like I said, that's like the 60,000 foot view of what we're going to be learning about. We're going to discuss the syllabus now, and then we're going to dive back down and start looking at Java in a little more detail. Now, as you may have caught on by now, I like it when the class talks back to me. And I don't mean in a rude way. I mean, answers questions, or better yet, asks questions. And I'm constantly asking questions. I'm quickly seeing that if you want to do this with me, you're going to have to talk really loud. Almost shout like you're yelling across the yard or something. This is a huge room. And I feel like I'm leaving you folks over there out, so I may have to wander over there from time to time so I can see your faces. Large room. Okay? So if you have any questions at all, please ask. The only questions I ever refuse to answer are the ones that are too advanced. So sometime I'll be going along talking about the basics of Java, and someone that's been programming for a long time and knows Java inside and out will ask me some really esoteric question that I could answer, but I don't want to take the time and bore 99% of the people that just aren't going to follow don't even understand the question. So when I get questions like that, I'll say, let's talk about that after class. Okay? So if you hear me say that to someone, don't be discouraged asking your own questions, thinking I'm going to shoot you down. But no question is too basic to ask, and any question you ask, there's going to be 50 people in the room that are glad you did. So I rely on it, so do other students, so let's do that. Okay, so there's the syllabus, and it's linked into Canvas. I'll show you where in a bit. Lots of information. So the first thing you should do is read the syllabus. I know it's a word salad, but it's sort of my contract to you about how this semester is going to run. So your time reading the syllabus will be well paid. And you're going to spend a lot of time in Canvas. As you know, the lectures are here and now. They are going to be streamed to YouTube, live streamed if possible. The labs are on Tuesdays, and there's 2 rooms they're in. Some of the labs are in MEB 3225, engineering building, one of the engineering buildings. The other labs are in MEB 3167. But if you look on your schedule, you won't see 3167 on it. Instead, you'll see Web L126. So if your lab is in Web L126, that's what your schedule says, or if your schedule for your lab says TBA, you want to go tomorrow to Web 3167. I'll send an email out about this after class. And we'll post notes down on L126. But both labs are up on the 3rd floor of the Merrill Engineering Building. Okay? So lectures are big. They'll get smaller. I know that from experience. Labs are small. They start out, they each have about 30 people. Now, how many of you need to add the class? How many of you want to add the class? Okay. So there's still seats available. You need to see me after class, and we'll work on that. Okay, there's a book. It's an online book. It's a company that calls it a Xi book. So it contains reading, and typically it's not like a whole bunch of reading. You read a little bit and do an activity. Read a little bit and do an activity. So there's information on Canvas about how to subscribe, $58. And the activities that it contains are due at regular intervals. And I'll talk more about that later. I'll be giving you weekly programming assignments. So every Thursday or Friday, I will post an assignment for the following week. So PS1, problem set 1, will come out Thursday. And you have until the following Thursday to do it. Now, I know things happen. So you can give yourself, 4 times during the semester, you can give yourself a 1-day extension on the assignment, on the problem set. And you don't have to ask me. You can just take it. So if you get sick, you don't have to tell me, just take the automatic 1-day extension. Okay? You don't have to tell me why, and I do that because I don't want 350 people asking me for extensions on assignments. So I just leave it to you to do that. Same thing with the labs. You're graded on lab attendance, but you can miss 3. You pick. There's a midterm and a final. The midterm's on October 17th in place of class. We'll have it in here and also upstairs. I want to spread you out a bit. So we'll be in the rooms directly above this room. More about that later. And the final is on Wednesday, December 19th, the finals week. That's just when it is. I don't pick it, it's given to us. Yes?
Finals week is the 10th through the 14th.
Your syllabus says it's on the 12th.
I got it a week late. Thank you. Yeah. I don't like, thank you for pointing that out. Okay, so plan on that. We're going to program in Java using Eclipse, a programming environment, and that's the subject of the lab tomorrow, is to get started. You need to bring a laptop to the labs. If you don't have a laptop, there are a few you can borrow, but ideally, I'll bring your own. Yeah?
I'm confused by what you say, what things are due Monday, Wednesday, Friday, and programming assignments are due most Thursdays, but we don't have class on Thursday or Friday.
Yes. So when I say things are due, okay, let me tell you in more detail now. So there are activities in the book. Some of the activities are labeled as participation activities, and they're really simple, easy things just to make sure you're staying awake. Then there are slightly harder ones called challenge activities, but they're not way harder or anything. And so I will give you sections, I will assign you for every lecture, I will assign reading in the Xi book. So for today, it was sections 1.1 through 1 point something. Okay? Most of you probably didn't notice that. And when I say stuff is due Monday, the participation activities that occur in the reading that I assign for a lecture are due before. Now that does sound good if you didn't do it, which most of you didn't. But that's okay. The first couple of weeks here, I understand, and I'll give you plenty of time to get caught up. I just want you to get used to the deadlines. So there'll be a participation activities, a batch due on Monday before class, a batch due on Wednesday before class. Then on Friday, there's a batch of challenge activities due. All the ones from all the reading that week are due on Friday. But that's submitted by, you do that in the Xi book. There's nothing to hand in. The programming assignments are submitted online as well. And the labs are graded on attendance. That's where your grade comes from. And there it shows us. The problem sets will make up 42% of your grade. The exams will make up 42% of your grade. And then you've got 12% for the Xi book, challenge and participation, and 4% for the labs. So that's 16% in the middle there that pretty much are free points if you'll just stay up with the course and do things on time and come to lab. And those 16 points could be the difference between failing and getting a B minus or something. So, don't fall down on that middle part. And I'm not impressed when people get hundreds on the programming assignments and 30s on the exams. I think something fishy is going on. And so my rule is if you want to get a C minus or better in the class, you got to get at least 60% on the exam. Your exam average needs to be 60% at least, and so does the problem set average. So that's not a really high bar, but it's just both are important. There's going to be lots of help available. I told you my office hours. There are 12 TAs. They'll have hours in a computer lab, and I'll talk more about that once I give you an assignment and there's something to do. All right, and then there's this whole thing about academic honesty or academic dishonesty. First of all, let me say that working with others is a good way to learn, and I encourage it. I think you'll do much better in the class if you find a study group and talk to each other, bounce ideas off each other. That is fine. I would do it if I were in your shoes. Okay? Your study group needs to consist of a group of people that are roughly the same strength. It's not a study group if you've got someone that's been programming for 5 years and then a couple of people that know nothing, because that's just, it's too imbalanced, and inevitably the person with the most experience is going to do all the work. So, sort of a smallish group where you talk over the issues, but anything you hand in needs to be in your own words. So if you come up with a group solution and then you all go off and type it in, that's cheating. Don't submit a group solution. In your groups, talk about how to approach the problem. Talk about ideas, but don't write a solution. And then you should be able to go off and make progress on your own. Okay, so there's a lot of gray area here. If you're worried about how you're working, how you're doing things, just feel free to ask. It's not going to be an issue until at least Thursday when the first assignment comes out. But the last thing I want to do is have a cheating policy that discourages cooperation. Now, I said you're going to spend a lot of time in Canvas, so I'm going to show you our Canvas page. This is the Canvas homepage. Up here are links that I thought were particularly important. Help. I'll show you these links in a second. So I've got these links, and here are links that Canvas puts in. There's a lot of duplication. Let me just start with help. So here's the help page. We'll have a schedule when me and the TAs will be available. Right now it's not filled in. This is a list of the TAs. This explains how to get help in the lab. This explains how to ask questions on Piazza, which is the system we'll be using. This shows you the TAs that will be in your lab. So
Go down.
this is a better table that shows what TAs will be in your lab. So it has various links. So if you want to know how to get help, come to this page. It'll be updated by the time you need help. Okay? That's the help page. Okay? This is the schedule page, and I put a lot of time into the schedule. I don't think a lot of people look at it. But anyway, right now, it's pretty succinct. It's just the first week. So you'll see the Monday lecture, and there's the link to the slides that I'm using, so you can access it. There's the lab for tomorrow, and there's the lab you'll be using in the lab tomorrow. You can see the topic of the Wednesday lecture. I don't have anything under there yet. Okay? And there's not an assignment there. In the semester, you'll have a whole record of what we did. Resources. These are sort of, this talks about how to access and use the Zybook, how to use Piazza, how to install stuff, and so on. So answers to technical questions tend to be there. Zybook, that's a link that will tell you how to subscribe to the Zybook. I won't go to it right now. Piazza is how we'll do all our classroom communication, so everyone needs to subscribe to Piazza. It's a free subscription. That link tells you how. This is a link to some Java documentation, and this is a link to our YouTube channel. See what's there. Why, look, it's live right now. It's not quite live. It's pretty far behind where we are right now. But anyway, when things are working smoothly, that's where the lecture shows up. And then there's a playlist that Stefan created for our class, which...
Right there, left.
That's 4150. Anyway, we'll get that straight. Okay, so that is that's the sort of things that you can find here in Canvas. One thing I'll call your attention to is the calendar here. Your calendar will show you all your due dates and all your classes that use Canvas. So you can see right now there was a 3 p.m. deadline today for P1M. That means participation activities, first week, Monday. There was one on Wednesday, P1W. That's Wednesday's participation activities. And then C1 here is first week's challenge activities. Those are due at 11:59 on Friday. So anything, I think the rule I'm going to use is any of these activities, these Zybook activities from the first 2 weeks, as long as you get them done by the day after Labor Day, then I'll call it good. Because people will be joining the class and leading the class. But after that point, you need to follow and get things done in time. Don't forget about them. Look at the calendar. Yeah?
So we just do the exercises and then we don't have to submit it or anything?
Yeah, he's asking about submitting. Just as you're using the online book, you'll do the exercises right in the book. Yeah?
Okay. I'm sorry to be basically repeating the question, just because I really want to clarify so I can understand. So the reason you have things due on Thursdays and Fridays, even though you don't have classes on those days, is because those things are turned in online?
Yes. Yep, everything's turned in online. And I've designed this class so you have something to do every weekday. Something's due every weekday. Zybook, lab, homework. Because a sure way to fail this class is to not think about the class at all until Thursday. So don't do that. I want you to think about it all along. I want you to have thought about what I'm talking about before I talk about it. That's why I have the Zybook assignments. Yep, everything's turned in online. So I think savvy Canvas users know about this schedule, and so they use it. Okay, so those are the highlights of the syllabus. Sort of give you the week-to-week feel of the class. It will make more sense as we go along. Are there any other questions I could answer before I do something else? Yes?
How are the Zybooks graded?
You ask, how are the Zybooks graded? So if we go back to assignments here, it turns out that, it says 48 points right there. There are 48 participation activities, or there are 48 parts of participation activities in the reading for today. So you get 1 point for each one you do. And basically the grade is based on what percentage of the points that you could have done, you did during the course of the semester. With some, it's like there's some slack, so you don't have to get perfect. You don't have to do them all to get a perfect score. But the details in the syllabus about that too. Yeah?
And there's no submitting for the online stuff, you just see it in our grades?
Yeah, you don't have to submit anything in Zybook. I can go and look and see what you did. Yeah?
Does it based off of participation, or is it like you get it right?
A lot of the participation activities, it's almost impossible to get it wrong. Yeah, so it's just doing it. The challenge activities are simple programming exercises, so those you have to get right. Yeah?
So are we the assignments like submitted via Canvas or like on Eclipse?
Okay, so the assignments, you submit to Canvas, but we're going to give you a tool, a plug into Eclipse, so you can submit it to Canvas from Eclipse. Yeah?
Will there be extra laptops for labs?
Yes. We have 5 extra laptops between the 2 labs. There's not a lot. Since the main thing tomorrow is to get everything installed on your laptop, you should come and you can install it on the existing laptops, and it won't help you out at home or anything. Yeah?
Will we be working specifically on Windows or Linux, or does it matter?
Okay, he's asking about, does it matter Windows, Linux, Mac? No. No. You're working in Eclipse, and you can install Eclipse on any of those platforms. So none of that matters. Yes?
I know the PowerPoints are going to be, the lectures are going to be on YouTube, but will the PowerPoints be like the files?
Yeah, well, they're not PowerPoint, they're Google Slides, but yeah, they're linked into the schedule.
Oh, yeah, that's very important.
Yeah, they're linked in the schedule, because the nice thing about Google Slides is I can fix my mistakes, and then I don't have to upload anything. It just fixes them up in the cloud. So the links are in the schedule for the slides.
Huh. Sure did.
Yeah. Yes? No, the participation grade is Zybook participation. It's a little bit too hard in a class this size to keep track of who's asking questions. Question? Yeah?
So are the challenge activities just completed like along at the same time as the participation activities?
Sure, you can do them all at the same time, or you might get pressed for time and decide to put off the challenge activity because they're not due at the same time. Okay? All right, so along about now, I like to take a break in class. Because 80 minutes is a long time. So we'll take a break for a few minutes. Don't go too far. What I recommend you do is introduce yourselves to the people around you, because you're going to be with each other all semester. So I'll come get your question after I finish talking to you. So do that. now we're looking at Eclipse. So there are at least 3 popular development environments for Eclipse, for Java. Eclipse, NetBeans, and IntelliJ. We just have to be using Eclipse. It has the same relationship, Eclipse has the same relationship to Java as something like OpenOffice or Word has to a term paper. Right? You can write a term paper in longhand or on a typewriter. It's just more convenient to write it in an environment where you have spell checking and formatting, and it's easy to correct mistakes and stuff like that. Same thing goes with Java. You could write Java on a piece of paper, or type it more likely type it into into Notepad and then compile it and run it. It's just more convenient to use a tool to help. So beginning students sometimes get confused about the difference between the programming language and the programming environment. What's in this window here, actually the blue up there, that stuff up there, that's Java and Java comments. Everything else around it is the support. Okay? Now, I'm going to talk about this little program right here. But before I do that, I want to talk about where it came from. So I created the code that I was going to use today, and I put it into a project called CS1410 F180820. So that's today. And the way you can recreate it on your computer is you're going to learn tomorrow how to install a little plugin we created. And to use a plugin, you come to File, New. You come down to Project, and you find Canvas Project right there. Right? Now, once you've done that about half a dozen times, it'll start showing you Canvas Project right there, so you don't have to go looking for it. So you click Canvas Project, and it will, first time you use it, it'll ask you to log in to Canvas. So you have to authenticate yourself to Canvas. After that, it won't ask you again unless you change workspaces. So you pick what course. It'll probably only one will come up. It just shows you the courses that are using the plugin, and you're only using one. So you pick it, you click Next, and let's say you're interested in lectures. So you click on that lectures, you go to Next, and what will show up here is an entry for every lecture, the code examples that I use in each lecture. I try to put them up right before lecture. I don't always get it done, but eventually you'll have a whole list. So suppose you go home and you want to say, I'm going to see what Joe did in lecture today, my code. All you have to do is come here, click that, highlight the one you want, and click Finish. I won't do it because I've already got it loaded, and it'll copy it right here. Now, maybe instead you want the code that's used in tomorrow's lab. So I'll go to New Canvas Project. Again, same old course. Then I'm going to pick Labs, because that's a lab. And there's L1. That's a lab for tomorrow. And you can see there are lectures, lecture examples, there are lab examples. Most assignments, I'll give you a starting point. You'll get your starting points there. I'll give you solutions to assignments, you grab there. If you want to create a blank project, you can just do it right there. Okay? So that's just a convenient way for me to get my code to you, is to use this plugin. There are other ways to do it, but this is by far the simplest. So you want to use the plugin. Okay, so we have Eclipse here, and in this window here, we have a Java program. And I'm just going to show you what it looks like right now. So this is sort of what a Java program looks like. It's got stuff here that the computer doesn't care about. That's called a comment. That's something that's for people to read, for you to read. Down here is actual code. The stuff that isn't blue is the actual code. And if I run this program, it pops up and says enter degrees Fahrenheit. So I enter like 345 degrees Fahrenheit. I say okay, and it pops up. That's 173.8 degrees Celsius. So you can see what the program does. It's just a simple temperature conversion program. That's a traditional way of interacting with Java. You write a program, you run it. Now, I'm going to change things. I'm going to call this thing now main.x. I'm going to call this main. And I'll talk about the importance of that later. And I'm going to run it. And now, instead of doing a pop-up, it goes to the console window and asks for degrees Fahrenheit. So now it's like it's printing it out to the screen. And I say something, and it prints it out right there. So that's another way of interacting with Java, either with a GUI style, graphical user interface style, or keyboard console. Now, those of you that have used Python before, you probably know a different way of interacting with Python, and there's a similar way in Java. The plugin makes it particularly simple. So if I come here to File, you see down here it says U right there, so you can tell it's University of Utah. So you click on Launch JShell, and in the console window here, it opens what's called JShell. So now what I can do is I can just type things at Java, and it will run them for me. And I can type really simple things, like I can say, what is the value of 2? Now what do you think Java's going to say when I ask it, when it answers a question? 2. Okay, no big surprise. I may say, what's 2 times 6? 12. I may say, okay, what is the square root of 63? And it'll tell me. So this was only added to Java about a year ago. But it makes it a lot easier to experiment with programs and pieces of programs. So we'll be using this a lot, especially early in the semester. And you can run it even without the plugin, but the plugin makes it possible to run it inside of Eclipse. You don't have to go outside of Java to run it. Okay? So we'll do a lot with this next time. I want to make you aware that it's available here. So back to this thing here. Let me put it back the way it was. Let's look. I'm going to collapse the comment there so you can get the whole thing on the screen. Now, it'll take several weeks, if not several months, before I will explain every last thing that goes into this program. So at first, I'm just going to, I'll say, don't worry about the details, we'll figure it all out later. But for today, I'm going to take a little bit of time and just try to think, what is it that goes into this program here? So, first of all, you notice I keep changing those two things that are, this thing that says public static void main-x, and this thing called public static void main, they're called methods. Right? We'll talk about methods next time, or Monday or something. But you see, I kept changing the name from main to main-x. What do you suppose is going on there? I'd like to hear from someone that doesn't know Java already, someone that just figured it out sitting here. Yeah?
It depends. The X changes like what opens up.
Okay, he said it changes what opens up. The idea is when you run a Java program, you're running a main method in some class. So this whole thing is called a class. The class is called hello. So we're running hello, and Java runs the main method from hello. So by changing the name of main back and forth, I can change what happens and run the program. That's all that's going on. So I've got 2 potential main methods here, but I can only have 1 at a time. Okay. What do you suppose is happening up there where it says import? Import java.util.scanner, import cs14lib.dialogs. What's going on there? Yeah?
So Java has like a set library of functions that already work, and if you import it, you can use those functions.
Okay. So Java has a library of code that you can use. But you have to say what bits you want to use. And so when I wrote this program, I says, I want to use the scanner. Don't worry about what a scanner is. I just know that I want to use it. So I had to do that. And then I wanted to use the dialogues class. So I said I want to use those 2 classes. Now Java provides one of those classes, but who provides the other one? Where's the dialogues class come from? Yeah?
There's a special class you made. That's part of the CS14.
Right. It's a class I wrote for you, and when you create the projects with the plugin, you automatically get the code for that class, so you can use it. All right, so let's go on. Let's look at main here. So ignore the public static void main string args bit. Just think of it as magic. It's just got a right to write a main method. You can get Eclipse to write it for you too if you get tired of typing. Those 4 lines in between the braces are called statements. And statements do things. A statement does something. So look at that first statement. And again, ideally, I'd like to hear from someone that's never seen a Java program before today. What do you think that first statement does? Think we're brave enough to answer. Yeah.
It shows the input dialog.
Okay. It brings up that input dialog. What does the input dialog say?
Enter degrees.
Enter degrees F, and you will type into that, and then you'll hit OK. And then what happens? What else does the statement do? Someone else tell me. Yeah?
The first statement still or the next statement?
The first statement, that show input dialog.
Has a input box for you.
Right, we type it and I hit OK. What happens to what I typed? Yeah?
It stores it as input.
It stores it into what that thing, string input is a variable. It's a place where you can store something. So whatever the user typed is stored in that variable input. I could have called it anything I wanted. Input seemed to make sense. Now, why were you able to figure out what this did, besides me telling you, reassuring you? Yeah.
It's pretty easy to read.
It's pretty what?
Pretty easy to just read and kind of figure out
Right.
what it does.
Show input dialog is a pretty good clue as to what that does. Now, if you're not sure what show input dialog is, you can go into Eclipse and hover the mouse over that, and up pops the documentation for it. You can read what it does. Now, what if I'd been lazy the day I made the program, I made the library, and I just called that thing F? Instead of calling it show input dialog, because who likes to type that much, I just called it F, because F is easy to type. Would the program have still worked?
Yes.
So why didn't I do that? Why don't I say typing? Yeah.
Proper documentation.
Well, he said proper documentation. Yeah. Yeah, it makes it easy to find and use. Yeah.
Somebody else uses it, they actually know what's going on.
Yeah. You know, maybe I would know what F did, but I mean, certainly easier for you just to see show input dialog. That's what I'm talking about. One of your audiences when you write a program is other people. Your main audience actually is other people. Okay? So, let's get executed one after the other. So you can see what happens is the input dialog pops up. The user sees enter degrees Fahrenheit. The user types something. It gets stuffed, whatever the user types gets stuffed into that variable input. Now what if you wanted to change the program so instead of saying degrees F, it said degrees Fahrenheit, enter degrees Fahrenheit. Any of you non-Java programmers think you could change the program? So that it said something else in the input box? Yeah? Yeah, you just added that blue text. Now, what if you are pretty sure that editing that text will change what's displayed by the input box, but you're not sure? But you're also a little afraid that if you change it wrong, something embarrassing will happen. The TA will make fun of you. Okay? Or, you know, or worse. Yeah?
Try it, and if it doesn't work, click the back button.
Yeah, try it. If it doesn't work, undo it. Don't be afraid to try things out. TA's not going to laugh at you. You know, no alarm will sound. You know, make simple changes, see what happens. That's how you learn. So anyway, it does that. This next line, so input is just the stuff that the user typed. This next line of code converts input, the string input, into an actual number inside the program. Stores it in another variable. What's the third statement doing? Yeah?
It's taking the input statement, the variable, and it's turning it to Celsius.
Okay, so it's taking tempf, which is some number, and it's doing some manipulations. It's just using the formula for turning numbers from Fahrenheit to Celsius, and storing the result in that place temp C. And then the last line is just displaying the result. Now, what does it mean to add the string degrees C and the number temp C? What sense is that? How do you add up some English and a number? What's going on there? Yeah?
Just concatenates them so they show together.
It's just concatenating. It's just gloming them together into a single string. And that's what's displayed. So these, you know, these are all details. I'm not expecting you to be able to read this coming in. But I am expecting you to be able to look at it and say, yeah, you know, that makes sense, and I could make simple changes to this. Right? What if I ask you to write a program that takes in two degrees in Fahrenheit and degrees in Celsius, and does something with both of them. Maybe it takes the Celsius and converts it to Fahrenheit, and takes the Fahrenheit and converts it to Celsius. Think you could do that? Sure. I encourage you to do that after class. Get Eclipse installed, download this thing, make some changes to it. You're programmers now. It's pretty simple. Okay, so that's how that works. Now, I want to show you something else. You'll learn about this eventually. I'm double-clicking right there. I don't know if you can see that, but it put a little circle out on the left. And now, before, I ran the program by clicking on this little go button, I guess. But here's a bug. I'm going to click on the bug to run it instead. And when that happens, the program runs until it gets to the place where I have that little dot. It's called a breakpoint. So it stops right there. So we can look at that and we can say, okay, if I execute that statement, something will happen. And so let's put a breakpoint right here. In fact, I'll put a breakpoint on every line of code. And I'm just going to run until the next breakpoint now. So, problem is, up popped the thing, but it popped up down here. It's a problem debugger. So I enter that, and now it tells me I'm here. So what does the input, what does that input variable contain at this point? 768, is that what I typed? I'm going to hover the mouse over it, and it'll show me 786. So it contains the string 786. So we can, by doing this, you can step through the program and watch what it does. So I'll run to the next breakpoint now. Now what do you suppose is stored in tempf? The number 786. It's hard to tell the difference, but in one case it was a character string, the next case it's an actual number. Now let's get the next statement. Temp C now ought to contain a Fahrenheit number. And now I execute the program to the end, and up pops the answer. So this is called using the debugger in Eclipse. And you'll eventually learn how to use it, and you can see what's going on step by step. So that's the main method. Now, let's change it back. And let's run that. Well, I already ran it. Let's just look at it. So we got a little bit more stuff in the program this time. What's the first line going to do? System.out.print. What that does is just going to display enter degrees F. Depends where you ran the program. If you ran it from Eclipse, it'll show up in the Eclipse console. If you ran it from a console window on your computer, it will show up in the console window. Now, it turns out to read from the keyboard, we have to create what's called a scanner object. So whatever that is, it gets created on the next line. Then we ask the scanner to give us the next line of input entered by the user. So whatever the user types on the line, the scanner will get. Then we do what we did before. We turn it into a number, we do the math, and then we print it out. But what similarities do you see between the two programs? Between the two main methods, I should say. Do they have anything in common? No. Same variables and also the exact same code right there. The actual code that does the conversion in the math is the same. This stuff is the same. So they're more similar than they are different. Yeah?
Their purpose is the same.
Yeah, their purpose is the same. So, if you're able to write that first program, you just have, you want to turn it to the second program. You don't have to change anything about you don't have to learn anything new about temperatures. You just have to learn something a little new about how to do different kind of input and output. Okay? So that's the story. We've got these two ways of interacting with Java. We either write main methods, or we use JShell. And we'll do some of both. I'm going to show you one more thing, and I'm going to let you go. Back to, let's see, what am I doing here? I need to go back to this. Okay, remember we have the plugin. So now I'm going to right-click on that, And I'm going to come down here, and you can see I can launch JShell from here as well, but there's this submit thing. So suppose this wasn't lecture codes, but this was your assignment and you'd finished it. So what you would do is come down here to submit and click there. Pick the class. Then it'll show you all the assignments to which you could submit. It's taken a while to find them. And because it's running as me, it can see all the assignments for the semester. You'd only see PS1 or L1. So you would pick PS1 and you would click finish. And then Eclipse takes care of the details of packaging it up and getting it up into Canvas. Yes?
So will it show us submitted in Canvas, or will it show us still?
Now, once you submit it through here, you can go to Canvas, refresh the page, and you should see that it was submitted there. And I definitely encourage you, when it comes time to submit, to actually check that it got there. Yeah? Good question? Okay. Yes?
Do you have a file naming scheme that you want us to use?
Yes, but we don't need to go into it now. When I have assignments, I'll tell you how I expect you to name things. Yeah?
So we have to install the plugin first before we can do that?
Yeah, any of this stuff involving running JShell and Eclipse or having those view menu options show up.
Repeat the question.
Okay, you want to know, do we have to install the plugin for this stuff to work? Yes. The stuff that has to do with Canvas and stuff that has to do with JShell, you need to install the plugin. That's part of the lab tomorrow. Yeah?
I went to the link of, when I clicked on the Java link on Canvas, but I'm not really seeing there's just so much information. I don't know what's important or what I should do.
Yeah. Okay, so she's
don't
looking.
know what to download or where to find the right plugin.
Right, so what she did was she went to the Java documentation. And I agree, it's not going to make much sense to you right now. We'll talk about that later. That's not the link you go to install Java. To install Java, you want to click on Resources. And then there's a link about installing Java. And again, that's pretty much the lab tomorrow. You'll install Java, install Eclipse, install the plugin, do a little bit of playing around like we did here, just to make sure you have the mechanics down so you can hand in your assignment.
Oh, we're going to
Next week.
install Eclipse in class tomorrow?
Yes, in the lab tomorrow you install Eclipse on your laptops. So bring your laptops. Let me just emphasize once more, if your lab says it's an L126, or your lab says that it's not anywhere, you want to go to MEB 3167. If you need to add the class, now is the time. Come see me now.